I'm Aruna, Assistant Professor, Department of Information Technology, SNS College of Technology. In this video, I'm going to teach about the normalization. This is a very important topic in database management system because all the database must have the normalized one. So without any redundancy must be present inside the relation or a database. So only I'm saying normalization is a very important topic. First, we're going to see the definition and what are the drawbacks over here. Then we can see what are the different types of normal form. So in this video, I'm going to give you the clear explanation about the normalization. So normalization is nothing but the process of minimizing the redundancy from a relation or a set of relation. So either maybe a single table or it can contain multiple tables. So in all the cases, we have to minimize the redundancy because according to the truth or a myth, we can't able to remove all the redundant element. So only we can able to minimize the redundant data. So never we can't able to remove all the redundant data. So only way is we going to minimize the redundancy present in the relation or a set of relation. So how the redundancy can be occurred in the particular database or a database table. So this can be occurred in the relation only based on the anomalies. One is the insert anomaly, deletion and update anomalies. So next I'm going to explain about what is the anomaly and how we can able to overcome this thing and all. We're going to see it in the upcoming slide. And also, if we are removing all these anomalies in the particular database, so only we can able to minimize the redundancy in the relation. So this is called normalization. So normal form, we are having the 5 different type of a normal form. One is the first normal form, second normal form, third normal form, and also Boyce code normal form. This is a very much similar to third normal form, Boyce code normal form. This is in a second version of third normal. After that, we are having a fourth and fifth normal form. So each and one is evolved only the drawbacks of the previous form. So how the normal 2 can be evolved means there is some drawbacks in 1. So only the 2 is evolved. So there is some drawback in 2. So only the 3 is evolved. So 3 also having some drawbacks. So only Boyce code normal form is evolved. So this is 3 basic normal form present. Extra the thing is the 4th and the 5th normal. These are the things we're going to study in my upcoming slides. So in this slide, I'm going to explain about the normalization along with the example. Let us see with the example. So we know that normalization is the how we can reduce the redundant data. Here I'm giving the basic example. One is a student ID, basic table, that is a basic relation. The relation can contain the 6 columns, that is a 6 attributes. SID, that is a student ID, student name, credits, department name, building, and the room number. Now we can check, is there any redundant data present in this table or not? So definitely, is there any redundant data is present? Yes. So here, CSC. The same thing. If Rahul and Jia, I have to enter CSC for both the students. If, for example, this table can contain thousands of entry. In that thousands of entry, 150 entries or belongs to CSC department means each CSC department, I have to write, I have to put the entry for the same data. So this can be called it as a repetition. So many entries for the millions of entries. So how we can reduce this thing means we're going to split that is a decompose. So totally we are having either we can need the decompose or we doesn't need the decompose. In this case, definitely we need the decompose. So we have to divide the larger schema into a smaller schema. So only while dividing this thing, only we can able to same type of a data, we no need to enter the thing. So only we are dividing the larger relation schema into a smaller relation schema. Similarly, FT, that is a fashion tech or a food tech having the same entry. Similarly, we are having, is there any similar entry? Civil also same similar entry. Here only you are having a 2 thing. So if you are having a 150 entries, each 150 entry, I have to put the same entry. So this is a redundant data. So this is called a normalization without normalized table. So only we are going for the normal form to removing this redundant data in the particular table. So in the normalize, I'm going to splitting the table. So again, I'm going to include the two more fields, that is a HOD name or HOD phone number. So for all CSE, definitely a single HOD. The same HOD for the all the CSE students, and also her phone number or their room number will be the same. So each and every CSE, I have to update all these things. So it is very difficult process. One changes in the database is very easier. If I want to change the 150 entry or 200 entry in the particular relation, it is difficult, very difficult to enter the data. So only we are going for a normalization. So if you want to enter the department alone, I doesn't have that thing. If I want to add the department name alone, that is a mechanical. I need to enter B1 and 301. So in this table, see here, so I doesn't have any student name, student ID and credit. So all the thing I'm going to put it in a null value. So only if I want to add the thing. So if these are the thing, there is a problem in the normalization. So only we are moving for the various types of a normal form. Because if I writing over here, so many null values is present in the particular relation. This is not a good database. This is also a redundant data. So only we are going for a normal form. So before going for the normalization, why do we need the normalization? Means we have to remove the anomalies, that is the insert, delete and the update anomalies. And also if you want to failure to eliminate the anomalies, that is also causes of the redundant data or data integrity and other problems as the database grows. That is if you want to enlarging the database, definitely we have to cause these problems. And also we have to see the data anomaly. Data anomaly is nothing but the multiple copies are present in the same table. That is a multiple copies of that particular table or a relation can be present in the two placements. One is updated, another one is not yet updated. So we doesn't know which one is the correct, because we are having two copies. In that, I can't able to choose which one is the corrected data. So this type of a problem only we can call it as a anomaly. Anomaly, we are having three different types. Either will be insert, delete or a update. In these three cases only, a redundant data can be enabled. So first we're going to see one by one. One is the insert anomaly. Insert anomaly is nothing but referred to when one cannot insert a new tuple in the relation due to lack of data. One cannot enter the particular way. Delete anomaly means refer to the situation where the deletion of a data result in the unintended loss of the other importance. Because if you want to delete the ECE department, I can't able to remove the ECE department in that particular table. If I want to remove the thing, the entire data will be closed. This will be the data anomaly. Update anomaly is when an update of the single data level require multiple rows of the data. If I want to change the room number of CSA department, I have to enter for the 150 entries. So these are the various anomaly. I'm going to teach you along with the example. So see here, this is my table. In this thing, what is the insert anomaly? Insert anomaly is nothing but if I want to insert the extra department, that is the I'm going to insert the mechanical department. Here mechanical B1 and 301 I have to enter. In this case, I doesn't have the value of the student information. If doesn't have means database automatically take the null value. So it will take the null value. So whether this is a good relation? No, because it will have so many null values. This can be called it as an insert anomaly. The next one is the update anomaly. Update anomaly is for checking. So I'm having a CSC B1 and 101. This I'm going to change it for the CSC C1 and 401. So in this table, I'm having only the 3 entries. So I can easily change the value. If I'm having a 150 entry in this particular table, I can't able to change all the values. It will take so many times. And also it will give the extra burden to the database architect. So this can be removed in the particular relation. That can be called it as a update anomaly. The next one is the last one is the delete anomaly. In your delete anomaly, if I want to remove that ECE department, if I want to remove this ECE department means, so directly if we are removing this thing is in the table, they doesn't have a ECE department. So, for example, a college can contain, college can without the EC cannot have without the EC department, but we can only possible to remove the from the EC department. We can able to remove only that particular student. If I remove it over here, the entire table will be removed. A table does not have a EC department. So this type of a problem we can call it as a delete anomaly. So these all the thing how we can remove this thing means, so only way is we are splitting into two things. One is I'm going to decompose the relation. In this particular relation, I'm going to decompose into two tables. One is a student table, another one is a department table. So in the student table, I'm going to give SID, S name, credits, and department name. Here in our department name, department name, building number, and the room number. This is in my department table. So what is how we can establish a relationship between these two tables by using the primary key and the foreign key. Here I am setting my student ID and the department student ID and department name is the primary key. So here I am going to act it as this is a foreign key because this one is a primary key. So we can able to access this one by using a foreign key. If suppose this is my, for example, here in this particular table, I'm going to consider department name is my primary key, means in this particular table, department name can act as a foreign key. So through that, we can able to establish a link between the student and department table. So in this case, definitely we can able to change the particular data. There is no bother about the thing because this is an individual table. Through that, we can able to remove all the thing. And also here we are having the two types of a processing. One is OLTP, another one is OLAP. So these and all the thing, while seeing the introduction part, I have teach you the OLTP as well as the OLAP. So OLTP is nothing but transaction processing. The another one is the analytic processing. Why I'm saying this one over here means, so where we know how we can decompose and where we can use this decompose the relation table, that we're going to know. So first we can take OLTP. This is a transaction processing. So in that transaction processing, so it will, the transaction can be taken place between time to time or minute to minute, second to second. So definitely I can't able to do all the updation in the table. Definitely in this case, we need the decompose the relation. The another thing is the analytical processing. If the database can contain any historical data, one is related to another one. So definitely here we need the non-decomposed data. So that is a non-normalized data. So before going for this particular solution, so whether my particular database is required or not. Normalization is required means you can go for decompose. Otherwise, you no need go for a decomposing the table. So what are the benefits out of this normalization means we can able to reduce the redundancy in that particular table, and also we can able to save the space because all the redundant data can be eliminated, means your storage of that particular data in the database is very much less. So only the compact of the data, or we can able to save the space. And also by using this normalization, we can able to remove, insert, delete, and update anomalies. And also we can able to minimize the null values. So by using this anomaly updation only, anomaly removal itself, we can able to remove all the null values. And also we can able to see that the query is very simplifying, and also your database is very simplified structure. So it is easily understandable. These are the various benefits of your normalization. And also according to the conclusion part, what are the thing we discussed in this video is, we are seeing about the normalization, why need to go for a normalization, and also with the help of some example, I have teach you what are the anomalies present in that particular table, that and all we can teaching over here. So this is a basic thing. In my next video, I'm going to teach you the normal form. Before going for the normal form, definitely we have to know about the normalization process. So only I'm taking this video for you. So if you have any doubt, please give comment in the comment box. Definitely I will resolve all your doubts. So bye bye. Next video, I'm going to teach you the normal form. Thank you.